Hey guys, I'm glad you're able to find this video. Today we're going to be talking about circuits. So before we get started into that, I want to talk about what types of objects charges can flow through and what they can't. So there are two main types. We have conductors, which allow the movement of charges or electrons. And we have insulators. And these tend to resist the flow, or they don't allow movement as well. So the reason why we're talking about this is because last week we talked about static, and static tends to stay still, really. That's what static means. Whereas we're going to be talking about circuits, and circuits are the moving of the electrical charges. And moving of electrical charges actually form a current, electric current. So to have a circuit, you must have a closed loop, or it won't allow the circuit to continue. We usually draw it as a square, where the electrons can travel through. If you have it open, it doesn't allow the electrons to travel because they hit a dead end. And it's kind of like a big lineup, so if one can't continue to move, the others can't. So it always has to be a loop. But on these loops, we can have a bunch of different things. And I briefly spoke to a couple people about how I'm going to destroy how you think of common words a little bit. So, anywhere in your house, I'm sure you can find something that looks like this. And you tend to call it a battery. In science, it's not a battery. It's a cell. An electrochemical cell is something that converts chemical or transforms chemical energy into electrical energy. So one of these is a cell. In science, if you have two or more cells, that is a battery. So basically, we've been misusing the word. We also call cells and batteries, so cells and batteries, sources, because they are where the electrical energy comes from. We have a whole bunch of symbols that we use for different things. So a line and a little line, this is a cell. If we have multiple of these together, this is a battery. A plain line is a wire. A bulb, or a light bulb, there's a few different ways to do it. These can all mean light bulb. This one, though, is actually a standard symbol for a load. And a load is anything that slows down the electricity. It usually is something that converts it to some other type of energy. So this can be anything from a clock, a light bulb, a buzzer, even a resistor sometimes. Another way to also show this, that your textbook sometimes shows, is this. And this, as you move on, and if you take anything like electronics, this is also the symbol for a resistor. And then we have switches. So an open switch, which means the electrical energy cannot move, or a closed switch. We do have other symbols that we'll be looking at later on next week. Things like a voltmeter, an ammeter, but we won't be looking at those until later on. So this week, what you're going to be doing is you're going to be practicing drawing your circuits. But again, you have to make sure that they're closed circuit. So we're going to have a complete circuit that it can travel around. You also have to make sure that you don't have something called a short circuit. So let's say that we are going to do 2 cells with an open switch and a light bulb. So we generally draw these with straight lines. You can do it a few different ways. You can draw your square first, or you can draw it as you go. So if we have 2 cells, we're going to have one big line, one little, one big line, one little. An open switch. I like to make mine appear on different sides. This just allows me to have it more clear. And a light bulb. And then I have to close it off. So you can see that it's going to travel through out of the cell, or cells, the battery, through the switch into the light bulb, and then return to the battery. If you have a short circuit, you may actually have an extra wire. And this extra wire would allow the movement of the electrons without going through a load. What happens is, if it's not going through the load, then the resistance is too low, and the current would get high. What happens, this is how you actually get electrical fires. So we don't want to have a short circuit. We want to have our straight square. There is another way to draw these though. So say we have 2 cells, an open switch, and 2 bulbs. One cell, 2 cell, our open switch, and there's 2 different ways we can do this. The first way, we can draw it in series. And in series means in a row. This also means that the electrons only have one possible path. But there's another way we can do it. We still have our two cells, we still have our switch, but what we could do is we could have one bulb here and another here. So this is called in parallel. What it means is that when the electrons are traveling through, they can either turn here or they can go through this wire. So it means there are multiple possible pathways. So you'll see questions that say things like, you have 3 cells, a switch, and 3 bulbs in parallel. So we have 3 cells, our switch, and then we have 3 bulbs in parallel. So it means that we need to put them on separate pathways. That was way too messy. This could also say the exact same thing, but at the end say in series. And that just means one possible pathway. So your assignment this week is going to be practicing drawing your different circuits. You're going to be practicing both parallel and in series. If it doesn't say anything, assume that it is in series. If it specifies in parallel, please make sure that you do that portion in parallel. I hope you guys have a great week.